Alright, hey guys, so I just want to make a quick video to go over simplifying radicals in case you missed this lesson. So how do I simplify radicals? So today we're going to be talking about, it's kind of like if you can think, so for example, if I had the fraction like 10 over 12, okay? And back in the day, your teachers would say, simplify this fraction. And we would reduce the top and bottom by 2, and we would get 5 over 6, yes? So these two things, they are equal to each other, but one is just in its most simplest form. So we're going to be doing that today with radicals. We will be given one radical, and we're going to put him into his most simplest form. Alright, so what is a radical? So a radical is this funny little thing essentially it really does have to do with squares. So kind of what I showed everybody was something like this. So if I have a square, this was originated in using like architecture and stuff and building things. So this would be like a 3 by 3. Well, the area here is at 9. So the area is equal to 9. So we would say that the square root, or like the side length, in order to achieve this area of 9, one of the side lengths of the square would have to be a 3. Okay, so we know that like the square root of 9 is equal to 3. So that's kind of what we're going to be talking about. So basically it's a number that when multiplied by itself gives us this thing that we call a perfect square. Now whenever I take the square root of my perfect square, for example a number like 9, we get back to that original number, okay, because 3 times itself gives us 9. Now is there another number that when multiplied by itself gives us positive 9? So we know that 3 times 3 is equal to 9. Is there something else that whenever I multiply those two things, something by itself, I get 9? Think. Okay, so what it is negative 3 times negative 3, right? A negative times a negative is equal to a positive. So sometimes whenever somebody says the square root of 9, sometimes people will say, well, that's equal to the positive and negative 3, right? Positive 3 times 3 is 9, and then negative 3 times negative 3 is 9. Okay, just a little side note, we'll mostly just be playing with the positive of them though. Alright, perfect squares. What are perfect squares? So perfect squares are these numbers that we multiply numbers by themselves and we get these numbers that we call perfect squares. So for example, what is 1 times 1? 1. What is 2 times 2? 4. 3 times 3? 9. 4 times 4? 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. Okay, hopefully you're seeing the pattern here, and this goes on forever and ever and ever. So there's not all of them, just a small little chunk of some of the perfect squares. Now I was telling my other classes, I don't want you guys to necessarily memorize these numbers, but they should stand off the page whenever you go to look through these problems. Like these should be recognizable numbers that you know, hey, I know that the square root of 1 is 1. I know the square root of 2 or 4 is 2. I know the square root of 9 is 3. Square root of 16 is 4, 5, 6, 7, etc. Alrighty, so again, these are what we call our perfect squares, and if I take the square root of those things, for example, the square root of 49, we would get this 7, okay? So those are our perfect squares. Okay, so here's a couple of practice problems. Simplify. Alright, so again, similar to like how I mentioned in the beginning, we have those fractions and it'll say to simplify these. Put them in their most simplest terms. So hopefully you know what the square root of 64 is, and if you're unsure, you can always get your calculator and pull that up, and let's say I want to do the square root, so I do second, and then we use the x squared button to give us that little square root sign, square root of 64. And it says it's 8. Okay, so the square root of 64 is 8. Again, it could also be negative 8 if we were being technical, but for our purposes, we'll just be rolling with the positive 8 for now. Alright, so the square root of 4, what times itself gives us 4? And the answer there is 2. What times itself gives us 25? The answer there is 5, right? 5 times 5 is 25. And what number times itself gives us 121, and that is 11. Okay, so again, the square root is just this one whole number. It's not, sometimes people will want to say, well, that's 5 times 5. Yes, 5 times 5 is 25, but whenever we're asking for the square root of 25, we just give one number, 5, okay? All right, well, what if it's not a perfect square? So you guys might remember learning this stuff maybe in 8th grade whenever your teacher would say, what's the square root of 50? And you would have to approximate it. Well, that's somewhere between the square root of 49, square root of 64, which are perfect squares. So that's 7, that's 8. So the square root of 50 has to be somewhere in the middle. You might remember that stuff from 8th grade. Our stuff's going to be a little different from that, but just pointing out the fact that you have played with these radicals before. So what if it's not a perfect square? For example, the square root of 20. So pull up my calculator. What is the square root of 20? And you see it's this long, infinite decimal. It goes on and on forever and ever. So it's not a perfect little whole number. He's not a perfect square. So these are going to be our steps for figuring these out. First, we're going to write out our perfect squares. Write out perfect squares. Okay. Second, we're going to look for the largest perfect square. I'm going to say perf square. We're going to look for the largest perfect square that divides, let's say divides nicely into our given number. And what I mean by divides nicely or like divides evenly, it divides as in a whole number. So for example, like 13 doesn't divide nicely into 20, but like 10 divides nicely into 20. So that's what I mean there. Our third step will be to use our little factor tree and simplify. And then last thing we're going to do is plug into our calc to check. Plug into calc and check. Okay, so let's go through these steps. So first, write out my perfect squares. Okay, I'm going to do that up here. So let's say I have 1, 4, 9, 16, 25, 36, and I'm actually going to stop there because I know 36 and 25 aren't actually going to divide nicely into 20. So it's kind of like if you remember these little factor trees. So for example, I know that 4 times 5 is equal to 20, right? 4 times 5 is equal to 20. Now with our radicals, sometimes we shorten the square root and we call these roots. So I might say root 20. So for root 20, let me back up a little bit. So write out our perfect squares. Next, we're going to look for the largest perfect square that divides nicely into our number. So I know, let's see, is 16 going to divide nicely into 20? No. Will 9 divide nicely into 20? No, not quite. What about 4? Will 4 divide nicely into 20? And the answer there is yes. So again, just like I said, regular 4 times regular 5 is equal to 20. Well, in the same way, root 4 times root 5 is equal to root 20, or the square root of 4 times the square root of 5 is equal to the square root of 20. So hopefully that makes sense. However, okay, so I did that. I found the largest one that divides nicely, and that was 4. Now we did the factor tree and simplify. Okay, so right here I can simplify the square root of 4 a step further, right? We know that the square root of 4 is 2. So this would reduce to 2 times the square root of 5. And that would be our final answer. And then I can plug it into my calculator to check. So I'm going to check, okay, I see what the square root of 20 is, right? It's 4.4 blah, blah, blah. And now I've reduced it to 2 times the square root of 5. Now think to yourself, should these two values be equal to each other? Think about those fractions. Whenever I reduced it, so like is 5/10 the same as 1/2? And the answer there is yes, right? They're just, even though they look different, they're still equivalent to each other. So the same thing goes here. The 2 root 5 is just a simplified version of the square root of 20, so it should be the same value. in which case it is. Okay, so that's a great way to check to make sure that you did simplify it correctly and you're still using the correct numbers. All right, so let's check out another one. All right, so the square root of 72. So first step says to write out my perfect squares. So I have 1, 4, 9, 16, 25, 36, 49, and I'm going to stop at 64 because I don't think 64 is going to divide nicely into 72. Let's try 49. So I'm going to go to my calculator and I'm going to do 72 divided by 49. Well, that doesn't divide nicely into there either. What about 36? 36 is the next one. 72 divided by 36. And there I see 36 divides nicely into 72. So I'm going to use my factor tree. So I have the square root of 36 times the square root of 2. But I know that the square root of 36 simplifies a step further because the square root of 36 is 6. So I'm left with 6 times the square root of 2. Pull up my calculator to double check. So the square root of 72 versus the answer that I got was 6 times the square root of 2. And again, these two things should be equal, in which case they are. So I'm good there. And I just want to show you guys what happens whenever you don't use the largest perfect square. So as you're working through these, you want to move in this order. Okay, you want to start to try to find the largest perfect square, and here's why. Let's say I just looked at 72 and I thought 4. Well, I think 4 divides nicely into 72. Or even 9. 9 divides nicely into 72, right? 9 times 8. So I want to show you what happens whenever you choose a smaller square root. So let's say I have the square root of 72 and I automatically thought 9 times 8. So that would be the square root of 9 times the square root of 8. Well, great. I know that the square root of 9 is 3, so I'm left with the 3 times the square root of 8. However, I'm noticing that 4 is a perfect square and he also fits into the square root of 8. So in which case I could simplify this further. Square root of 4 times the square root of 2. But I know that the square root of 4 is 2. So I'm left with all of this. Hopefully that's not out of the screen. Almost. Let me rewrite this or scoot that down a little bit. Alright, so I'm left with this 3, this 2, and this root 2. So if I write those things all out side by side, that's 3 times 2 times the square root of 2. Well, 3 times 2, those are regular whole numbers, so that's 6 times the square root of 2. So you'll see I still get the same answer. However, this way is much, much, much shorter, right? So as long as you're starting in this direction, you're working down the line this way, and you find that largest square root that fits into there, it's going to save you a lot of time and trouble. So hopefully you guys recognize the difference there. You still can get to the right answer, but it's a much shorter process if you use the largest perfect square. Alright, so let's practice a couple more of these. So the square root of 45, first step again, factor or write out your perfect squares. 149, 16, 25, 36, 49, 64, 81, blah, 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 forever and ever. Alright, so I'm going to be settled up with those for now. So looking at the square root of 45 again, remembering that I want to work down or backwards through these numbers. What's the largest perfect square that's going to fit into 45? Well, maybe I'm not sure. So I'm going to work backwards through those, and I'm going to see, give me just a second. Okay, so I have 45. Let me start with 45 divided by, maybe 36. That's not going to work. 45 divided by 25. That's not going to work. 45 divided by 16. Doesn't work. 45 divided by 9. Okay, so this is kind of the process that I want you guys to work through. I want y'all to work backwards through the line, and maybe on some of these you might not need a calculator. Hopefully you know that 36 doesn't divide into 45. Same goes for 25. But this is the process that you can use if you're unsure. So I see that 9 and 5 are going to work for me. So I'm going to break these apart. That's the square root of 9 times the square root of 5. But I know that the square root of 9 is 3. So this reduces to 3 times the square root of 5. Again, you can double check it in your calculator. I'm going to save myself some time since I know that's the right answer and not do that. All right, the square root of 98. I would work through the same process. I'm not sure what's going to fit into 98, so 98 divided by maybe 64. That's not going to work. What about 98 divided by 49? And there I see that it works, okay? So I'm going to factor these out to the square root of 49 times the square root of 2, but I know the square root of 49 is 7, so I'm left with 7 times the square root of 2, okay? Square root of 85, okay? Again, I'm working backwards through my line of perfect squares. Let me see if I can reduce this. Nope. As small as it's going to get. Okay, so 85 divided by, let's try 49. No. 85 divided by 36. 85 divided by 25. And then I know, or then 85 divided by 16. Okay, and I can keep going on, but ultimately the only perfect square that's going to work is going to be 1. In which case, anytime that only 1 is whenever 1 is your only perfect square, that works. Ultimately, your answer is just going to, that means that this is in its most reduced form. We know that the square root of 1 is 1. 1 times the square root of 85 is just square root of 85. All right, so similar, I can relate this to, think about like a fraction. If I said, put this in its most simplest terms, okay, 3 over 10, can that reduce any further? And the answer here is no. He's already in his most reduced form. So the same goes for here. Square root of 85, he is in his most reduced form. If 1 is the only perfect square that goes into him, he's just going to stay as is, okay? And then the last one over here, square root of 36. Hopefully you recognize the square root of 36 as a perfect square, and that's equal to 6. But let's say for maybe for some reason you don't recognize that. You got a little thrown off. So let me see, does 16 fit into 36? So I have the square root of 36. Oh, I'm sorry. You can just chunk it into your calculator. My recommendation on all of these is just to first plug it in and see, is it a perfect square? Oh, it is, okay, versus one like the square root of 85, in which case he's not. All right, so square root of 36, let's say I didn't recognize he was perfect and I tried 36 divided by 16. That doesn't work. 36 divided by 9. And there, that one does work. So I'm going to say the square root of 9 times the square root of 4. But I know the square root of 9 is 3. It's a perfect square. And then the square root of 4, he's also a perfect square, right? And that's 2. So this is saying 3 times 2, which is equal to 6, which is what I got up here to begin with. But just want to show you there's a couple ways to get to the right answer in case you don't recognize those as perfect squares. But hopefully, like I said, you'll be working with these numbers so much that these particular perfect squares, the 1, 4, 9, 16, 25, blah, 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 that all of these, I hope that these will eventually start to stand off the page a little bit more than all of our other numbers there, okay? Please come see me if you have any questions over any of these things, but we do have a homework assignment over this, so make sure that you got this from me too. Thank you.